Now, pointers and constants. Now, this is very useful when you want a variable to play a dual role. What do I mean by that? Let's say we have a variable a, and I like using integers. Let's just say string greetings is equal to hello, right? So this is, I think what I'll be doing, I'll be updating it. So let me just use an integer. It's quite easy to work with. So int a is equal to 9, right? Now, this is just a variable a, and it stores a value of 9. We have looked at constant variables where you can't update the values. So let's say that in a particular part of the program, you want to update the value. So when you use a constant keyword over here, you can't come down to any part of the program and then say that a is equal to plus plus a. That would throw a compile time error. So when we run this, we get an error over here because we can't update it. It's been declared a constant. In order to update it, we have to just declare it this way so that we can update it later, right? So we see that we don't have any error. But then in the particular another part of the program, you want to um, work with it as a constant. You don't want to update it because when you update it, it's going to throw errors at another part of the program. Let's say that a part of the program, you want to work with it as it is. If the value gets updated, if the value gets called elsewhere in the program, it's going to bring out unexpected results. So you want to use it as a constant. Now this is where pointers come in. You declare its pointer as a constant. So constant int, right? So this is the format. So constant int p1 is equal to the address of whatever variable that you have. So what did we do over here? The normal way is to declare it this way, which is just a pointer p1 pointing to which is the address of a. When we run this, we will not get any error. And then we can dereference this. Let's see out the dereferenced form of p1. So let's dereference it p1, and it's going to return a 9, right? So we get the 9 over here because that's the value of a. Then if we want to say that the new p1, and we saw that we can update the value, we can dereference it p1 and update it to anything that we want. We can say the new value should be 9, right? This is going to run perfectly, right? Now, as I have said earlier, what if you want to use this variable as a constant? You don't want to update its value because when you update it later on, when it's being called at another part of the program, it's going to return unexpected results that you don't want. So you want to use this particular variable as a constant and as a normal variable. So in this case, you want to make its pointer a constant such that you can't update its value. So when you put the constant keyword over here, you can just call out p1 and work out with it. You can call out the value and work out with it, but you can't update it. So let's go ahead and then just print it. See out. Let's just say dereferenced of form of p1 plus 1. Mind you, we are not updating the value. We are just picking the value 9 and adding 1 to it. So let's run this, and we should be getting a 10, right? And we got a 10 over here. So we have not updated it because when we see out p1 is going to return 9. When we see out the reference of p1 is going to return 9. Now what if we want to change it? What if we want to change this particular value? So let's say that the new p1, dereferenced p1 is equal to 10. Can we do this? Let's see if we can do this. So let's run this, and we are getting an error here. It says assignment of read only location of dereference pi1, it cannot be changed, so we can't do this. So this allows us to use the variable as a constant. You declare its pointer as a constant, and then you dereference it, and then you use that particular value to work throughout your program wherever you don't want to update its value but you want to use it as a constant, right? So that is pointers and constants. If I'm talking a lot, kindly inform me in the comment section because I sometimes just get out of topic.